Okay, lesson 47. We're going to talk about doing some vertical translations with these trig functions. So what we're going to do is we're going to look at this equation. You see how it looks just like this one. This is the parent function, and it's just this minus 3. So that's called a vertical translation. That's literally just going to go down 3. So we know how to graph the basic parabola, y equals x squared. It basically looks like this. We know it's 0. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4, right? Or when x is negative 1, it's 1. Or when x is negative 2, it's 4. So that's your basic quadratic function. It's called the quadratic function. It is called one of the parent functions. Okay? This is called the parent function. So, when you see a formula, it looks almost just like it, but there's just like a small change like that. It just means to take the same graph and take each of those points and lower them 3. So 1, 2, 3. This point needs to come down here. This point needs to go 1, 2, 3. This point needs to come down 3, which will be putting it at 1. Same thing with this one. This one needs to come down 1, 2, 3. And then you just graph that one. And this is the graph, actually. You know, this is that one. That's one you're really wanting. Start with your parent function, though. You know, and then graph the other one. Okay, so here, this is the sinusoid parent function. It's y equals sine of x. And you know how to graph that. So we know that it basically goes up, down like that. Okay? Now, this comes up to a 1. It goes down as low as a negative 1. It comes down, goes up, it comes down, and starts back over at 360. That's one complete wave. Okay, so that means, of course, this is 180, 90, 270, like that. When you do this, when you're adding 3 to it, it just means you're going to move it up 3. So, if this was 4 right here, I'm sorry, I said move it up 3. I don't know why I said 4. Well, because I'm going to need 4. Anyway, if I move this up 3, 1, 2, 3. If I move this one up 3, 1, 2, 3. Now I'm doing everything on this line. Moving this one up 3. Move this one up 3. 1, 2, 3. Move this one up 3. I'm going to be up here, aren't I? It's going to look the same. It's just going to be moved up 3. Okay? So those are translations. Now we know that this has a center line of 3, which is why it's up here, and it has an amplitude of 1. Another way to look at that is the translation. So let's do another one here. So if I have a, I'll make this a little bit smaller because this one's different. If I have a parent function y equals sine of x like this, so this is a 1 and a negative 1. This is telling you move it down 2. So this one's going to come down 2, so I need to have a negative 2. Now if I have a negative 2, I know that it's going to start here and go like this, right? So I know it's going to go down to negative 3. So I know this one's going to come down here. I know this one's going to come down there. And I know this one's going to come down here. Again, that's 360. I know this one's going to come down too. I know this one's going to come down too, which is going to be here. Except we got another little issue going on here. And that is I have 3 times the sine of x. It's not just sine of x, it's 3 times it. That's telling me my amplitude is 3, not 1. So if I graph that right there, that's an amplitude of 1. I want to change this point and this point to have an amplitude of 3. So instead of going from the center line up 1, I'm going to take the center line and I'm going to go up 3. 1, 2, 3. So it's going to go all the way up here. Okay? So you have some bearings on where we're going here. So this one right here, this is my center line. and I want to go down 3. 1, 2, 3. So the amplitude has increased as well as a change in a shift. So we're going to do this and like this. Okay, hopefully that's helpful. Let's look at the back. So there's some things you just need to know. What does this mean? Now, anytime you see arc sine, arc cosine, or arc tangent, you have these restrictions to these quadrants that you need to have memorized. What that means is when you're doing arc sine, you're going to work like this, either 0 to 90 degrees or 0 to negative 90. And if it's in arc cosine, you're going to work like 0 to 180, but never down here. And for this one, it's the same as the first one. So in these two quadrants here. So if it says arc sine of 1, that means the sine of an angle is equal to 1. What is A? That's what it's asking you. So you know that when is it 1? Think of your unit circle, and it would be at 90 degrees. So this means the sine of an angle is 1/2. And this one's going to be at 30 degrees. So this means the sine of an angle is equal to negative 1/2. Now, here's where you got to be careful because it's one of these two quadrants. So you're not going to say 330, you're going to say negative 30. So you got to stay right in between those two. You can't go into the others. So when is cosine negative 1? At 180 degrees. When is cosine 1/2? Well, it's 1/2 at 60 degrees. When is tangent negative 1? Now tangent is at negative 1. Now remember, we're in tangent, so it's going to be negative in this quadrant. So it's negative 45 degrees. And when is tangent undefined? Well, tangent's undefined here and here. Okay, so at 90 and at negative 90. Okay, so let's look at it in an evaluation problem. So we got to get the parentheses done first, just like always. So let's figure out the tangent of 135. Okay, so you got 135 degrees. So your triangle is going to be over here. That's 45. 1 square root of 2, but this one's negative. That one's positive. Tangent's going to be negative 1. So what angle has a tangent at negative 1? Now we've got to go back to this restriction. So it's going to have to be in this quadrant. We already talked about that once. It's negative 45 degrees. So this is negative 45 degrees. Okay, again, got to work inside the parenthesis first. So I want to know the angle whose cosine is negative 2/3. Okay, that's what that means. The cosine of an angle is negative 2/3. What is the angle? But arc cosine is only restricted to these two quadrants. So it's going to have to be this quadrant here to be negative. So I'm going to draw me a triangle over here. And I want this angle to have a cosine of 2/3, and it's got to be negative. And that makes sense because that would be negative right there. So I need to find now the sine of this angle, whatever it is. I don't necessarily even have to know because I can do Pythagorean theorem and find this side right here. Okay, so you would just do 3 squared equals negative 2 squared plus, say, x squared. Okay, actually it's y, so let's call it y. So this is 9. This is 4. Bring it to the other side. So you get that y is the square root of 5. So you know it's square root of 5. So the sine of this angle is square root of 5 over 3. Okay. So to here, we're going to find the cosine at 150. If I have 150 degrees, I've got 30 left over. Cosine of this is going to be square root of 3 because that's 1 and that's a 2. This one's negative. So the cosine of this is negative square root of 3 over 2. Now I'm back to arc cosine. It's got to be in one of these two quadrants. It's going to be this one. Now that's still the one I was in, so I can just use that same one. And what is the answer for this? When is it going to be this value? At 150 degrees. Okay, but if you're back in the same quadrant, you're at the same answer. So this means, right here, the cosine of an angle is 4/7. Okay, now I know it's got to be one of these two quadrants. It's positive, so obviously it'll be here. So if this is my angle, the cosine is 4/7. Okay, and I want to find the sine of this angle. So again, I'm just going to write like this. So that's 49. That's 16. Bring it over, it's negative. So that's 33. So y is going to be the square root of 33. So for this, I'm getting the square root. I'm sorry. Yeah, the square root of 33 is what y is. But for the, yeah, I'm sorry. So then I'm going to do the sine of this. That's why I just never said that to you. I'm sorry. So the sine of angle A then is going to be opposite square root of 33 over 7. Okay, hope that helps.